RTFI. Yes, it took significant time. I don't know, this presentation is not opening properly. No. This one? Yeah, that is true, but it is see, it's not responding. I'll ask only whether he is having anything in shared. We'll copy it. One, we will discuss about basic field rating. This you already know, but just an overview. Two, we will discuss about films, artifacts and image formation techniques. Three, these are the topics we covered. Three, we will cover about welding and types of welding. Four, we will cover about defectology in welding. Here, up to here, what we learned, maybe it will take 2 or 3 days, whatever it is. 1, 2, 3, 4. You will get a picture on what is welding, how are the defects formed. These pictures you will get. Now, from 5, what we will learn is here. We will learn about the defect appearance in the welding. From 6, after this one finish, you will start practicing. So these 5 are, you have to completely grab there, grab the knowledge. From 6 onwards, we will see on practice film. Whatever I taught, is it correct or not? In the film, we will. Are you okay for that? No. Okay. Is this presentation opening, or if it is not opening, we will leave it. Good that it opened. Yes. Okay. I don't want to go this. First of all, let us go to the basic field radiography. What is the principle of radiography? What is, my English is fast? Is faster? No. It's okay. What is the principle of radiography?
So we know the good news. Good or
yeah, but, correct. But what is it? There will be a principle. How the image is formed. You see the field, no?
Yeah.
How is it formed? You have any clue on that?
What?
How the film.
Yeah.
You have the film, right?
Yes.
How the image is formed? Image.
Yes, sir.
The welding image. How is it formed?
It's
Any clue? Yeah. Okay. Mm-hmm.
That's the go straight her and straight her.
Okay.
And then it's on
Mm-hmm.
then it's on.
Okay.
It's on.
So okay. But how will you, for example, see? Okay. Now, as you said that there is a welding. So this is a welding. Okay. Now you are saying that there is a radiation coming here, right? And this is the film. So how the image is formed? So it is formed like this, right? And this is darker. This is black. This is little white. In this white there are some black, some white, something like that, right? So why is this formed? Why?
So we can know
Yeah, correct. But radiation is coming uniformly, right?
Yeah.
So different densities. Why different densities are formed?
Because the thickness, the materials,
Correct.
Not all. If there any this materials come more down or more
No, less or more.
Which,
If there is less material,
this material down, more down,
more radiation.
more radiation.
Okay. Okay, for example, I have a hole here. Okay.
So it will come more dark and different.
Here more radiation or less radiation? Here. In this hole.
Yeah, more radiation.
More.
Yes.
So whenever people ask you for principle, what you need to answer is, can you read it? Yeah. This is the principle of radiography. If there is no differential absorption, there is no image.
No.
What you told is correct, 100%. What you told, if there is hole, there is more. What actually happening is, what you told is differential transmission. I am not saying differential transmission. I am saying differential absorption. Absorption is taking.
Yes.
So that means, for example, there is a weld. There is a block like this. Say there is a weld and there is a hole here. So what happens? The radiation is passing continuously and it will reach the film. So here it will be more transmission. But what actually happens is the absorption here is more and here it is less. Right? So the principle will be differential absorption. Means the material is absorbing differently. So for example, if I pass 100 rays, at one location it absorbs 50 rays. It will take inside and it will give only out 50 rays. At another location it will absorb 75 rays and it will give only 25 rays. So this is the major principle for the image formation. Otherwise you will not get any image. For example, see, this is the image. Why this image is formed? Why this is black? Why this is black? Because of the differential absorption. And your main area of interest is weld, right? So we also need to discuss one more thing. Aramco procedure. This is actually you need to really struggle hard. Codes and standards. Okay. So now you understand that differential absorption is the major principle, right? If there is no differential absorption, what happens?
It will become same.
Same. So you cannot evaluate. Okay. Now let us discuss about some other factors. You saw here, no? This is black. This is white. This is black. Something like that. What is this black and white? What is it called in radiography? What? Yeah. No. Tell me clearly. Density. What is density? Correct. Density is correct. What you said is correct. What is density? You need to go through. These are the basics. So if you wanted to interpret, you need to understand these things. What is density? No problem. Tell me.
We know what's the difference between
but you,
definition
ah.
the difference between two area.
That is not density.
It's too fast.
Yes. Density means the
How much
black the film is.
the
Yes. How much black the film is this. It is called, definition is the degree of blackening. Means how much black is the film is the density. Okay. Now in this film, for example, let us say this is the film. Okay. Now this is the film, right? In this film, where do you measure the density? Which location you want density?
And the side fall and the joint.
In the joint. So how you are able to see it, right? Very clearly. Why you are able to see? Because of the
Good density.
no. You are able to see not because of density. What? Tell me. And these are the basics. That's right. Absorption. Okay. But why you are able to see? You have TV, right? In your TV, if your contrast is 0, what happens? Can you see it? But the picture is playing backside, but you can't see.
Yeah, it will become more white.
Yes.
Or more dark.
More dark. So why you are able to see a film? Because of contrast. That means the density at one location and the density at other location is different. If the densities are different, you will be able to see the film. See whatever it is. If there is no contrast, you cannot see. So now what happens? Why you are able to see? Why your pointer is not coming here? Here. See, here there is one dark spot, right? Why you are able to see? Because the density is different here and here. What is this called? This is called contrast. Density. What is density? No problem. But you should understand this. Why you should understand this? Without understanding this, you cannot interpret the film. Why this is more dark? Why this is less than? You have a defect in the weld. What is this defect? How you will know? If you are having a defect in the weld and it is in the film, anybody can say, okay, there is a defect. But what is the seriousness of the defect is important, right?
Yes.
What is it? How serious is that? Is it a crack? Is it a porosity? Is it a slab? See how you will understand that. That is understand only based on the contrast, the ability to see. Of course, your technique should be correct and how you are able to see it. That then only you will understand. Otherwise, why RTFI people are failing? Because lack of fusion is there. They will say it is slag. Slag is very simple. You don't have any problem with slag. But lack of fusion, you have problem. It's a very serious defect. So interpretation's main goal is to exactly pinpoint the defects, the seriousness of the defects. If it is a porosity, if you say crack, then what is the use? Again the welder will go and cut everything, no? So you should know the exact reason of seriousness of the defect is important always, right? So, okay, now density is completed. You understand what is density? What is contrast? Contrast. What is it? Different density difference between two areas. This is perfect. Okay.
Contrast different density between two areas.
Yes.
And density, the darkness of film.
Correct. Exactly.
The darkness of
Correct. Exactly. No doubt of that. That is correct. So now, okay, I'll ask you a question. Now tell me. I have an object like this. Now I have a film here. Where will you get more density? Left, this is left, this is right. Okay? In the left. That is for sure. Now, this one is D7. I use another film. Which film is that? D4? Okay. Which film is good? Why?
Because it's slow and take a good distance.
Yeah.
More run.
Correct.
Fast.
So, you mean to say that D4 film is good?
Good density, but it's slow. So it will take more time.
D7?
D7 it will take fast time.
So,
but,
so what is the technical term? D7 is giving good contrast or D4? Good contrast.
good contrast in D4.
Yes. Okay. So, good contrast in D4. Eh? Okay. And in D7 is low contrast, right? So, what I am saying is that the contrast because of the film, not because of the object. Object I have given here. This is the object, right? I will draw it once again here. This is the object. The film is 2. So the contrast because of the film, not because of the object. Forget about object. If the contrast is more because of the film or less because of the film, it is called film contrast. Okay? Because that is the capacity of the film, not the object. Maybe object is having difference or low, whatever it is. If you are having, for example, this is like this. If you are having like this, simple. Also D4 is good. Any contrast, any job you use D4 is good. The same job if you use D7 is bad than D4. So the contrast due to film is called film contrast. Understood or any questions? This is very important. Okay. Now if there is like this job, uniform, as I asked you in the previous session. So what will happen? There is no density difference at all. Correct?
Yes.
So if there is no contrast in the job itself, job is uniform. That means your object itself is uniform. Then there is no contrast. So the contrast due to object.
Object contrast.
That is called subject contrast. Yes, object contrast also no problem. I am not fixed to the words, but it's called subject contrast. So how many contrasts are there? You have
Contrast,
subject contrast and film contrast. Which film has more contrast? D4 or D7? Which subject has more contrast? Because the thickness difference. Simple. If you have more thickness difference, you will have more subject contrast, right? The thickness difference. So for example, if I am having like this, obviously here subject contrast is very more.
Yeah, we will see. Side it will be up.
Yeah. So this total contrast is called radiographic contrast. Is equal to subject contrast plus film contrast. Okay? Now, can you explain me why? Yeah, I think you already know this. I will skip if you want. Why D4 is more giving good contrast? Why D7 low? You have idea? Okay.
Because of
Say this. Correct.
That's one. And D4 is different, so he take time to.
So what?
The high thickness already.
Yeah, correct. It takes more. Correct. See, a radiographer, if he does one day, you are not talking about you, somebody new guy. If he does one day, and I say D4 will take more time, this is D7 will take less time, he will also answer the same question. In the same way. I want it in a different way. Technically, you should answer me technically. Technical answers are important. Why? What is, tell me now. Now I am going to get basic. What is film consisting of? What is film? No, what is an answer? Why? Okay, why I open in the film it will become dark? Why? What? What is that? Ah, you should know your RTFI.
Yes.
Okay, the content is AG. What is this? BR. See, these are the very important facts. The reason is you will have one film very dark, very dark. You will say, oh, this is cracked, but it's not cracked. You see, maybe it is a defect, it is an artifact, it's a film defect. How you will identify? Until and unless you know this, you cannot identify. You should know that first interpretation technique is you should know the image is due to differential absorption or not. The principle is differential absorption. So the image formed on the film is due to what? This is the first question you should answer in your mind. When you see the film, for example, when I see the film, this image, is it due to differential absorption or not differential absorption? There are, in film, you will find lot of images, not due to differential absorption. Maybe your developer is a problem, your fixer is a problem, your hanging is a problem, your washing is wrong, anything, right? So this is more important. To understand that, you should know what is this. What is this now? AGPR is what? Tell me what is this? You stop reading, eh? Okay. Silver? Now you got it. See? You should recollect it. You are recollecting it. Silver bromide. So now in D4 also I have silver bromide. In D7 also I have silver bromide. But D7 I have like this, big one. In D7 I have small one. like this. Okay. So what happens when radiation comes here, hits it? How much area it is exposing? This much area is already exposed for with one ray. But here, with one ray, only this much area is exposed. Correct? So the area of exposure in D4 is very, very low because the silver bromide crystal is small. So obviously you need more time. Okay, now another question I'll ask. Today is questionnaire session, I think.
No.
Why you are, for example, D7? How much time? For example, say 2 minutes. Okay? D4, how much time you will give? 7 minutes. Yeah. Why 2 minutes? How 2 minutes? How did you decide that is 2 minutes required? What? Yeah, calculate. What calculation? I don't want about the calculation, but I want the concept.
Thickness and distance.
Okay.
Purity.
Okay. Everything. Okay, tell me everything you have taken. Okay, but there is one important thing. I will take everything and calculate such that the entire film is exposed. Right? What is that and how do I decide that? Okay, I'll tell you.
How I decide enough or not enough?
Yeah, how you will know? Okay, I'll tell you an example. I know a person. I got radiation. Okay. Forget about it. I got radiation and my finger broke. I received 1 MR. Will my finger broke? 1 MR. 1 MR. You know 1 microsievert.
Yeah.
Will my finger break?
No, it can't.
I received 2000 MR, 2000 sievert. Will my finger break? Maybe. Right? That means what happens is that every object, any object, me, human body, even air, feeling, any object, it requires some amount of. For example, I wanted to lift this phone. Okay? I say like this. Why is it not lifting? It requires sufficient energy, right? Against the gravitational force. For example, there is a gravitational force, say 100 psi. So now I wanted to lift this phone, then I need to put more psi, 101 psi. Then only I can lift the phone, right? In the same sense, if I wanted to damage an object, what you are doing actually in D7, D4, you are damaging the film, right? First film is very clean. Now, because of the weld, and your radiation goes inside the film and you damage the film. So to cause that, of course, this damage is for our usefulness. We are using the damage. So this damage, to occur this damage, some radiation is required. Quantity, definitely this amount is required. Okay? That you are calculating the time for that amount. That factor is called film factor. You know what is film factor? This is film factor. That means the minimum amount of radiation required. For example, for D7 it is 1.2 R.
في كمية محددة دراسة تجي أنا زي الفيلم قدام مقاومة ضغطت 10 مرات خلال فترة 20 سنة هذا القوة شو يسمونه يعني أقل شيء عشان تكثر إلى 0 خط فهمت كيف؟ الوقت هذا معين 0 خط أقل شيء تعطيه عشان يتذكر كل متوسط.
Okay, you got it, eh? Now this is film factor. So what happens for D7? You know about Röntgen, no? You know units, right?
Yes.
Units. What are the units? Tell me. 1, 2, 3, 4, something like that. Units. Yeah, microsievert, sievert. These are all for human body. For film, it is Röntgen, milliröntgen, something like that. Right?
No.
So, you heard about Röntgen, right?
Röntgen?
You don't know.
No.
You also don't know. Okay, I'll tell you. No problem. for example, what happens is, this is air. Let us say this is air. Air. Just
air.
air. Okay. Radiation passes inside. Okay, and creates ions, plus, minus, plus, minus. So you are measuring how much radiation is based on this charge. So for example, this is plus, this is minus. What happens to the plug? Everything plus, minus, right? So this total amount created is called Röntgen. How much charge is created? Like sievert, no? Sievert is nothing but Röntgen. I think 100 Röntgens is 1 sievert. 100 Röntgen is 1 sievert. But sievert is measured for human body. Röntgen is measured for film, air, something. Not human. Not human. So in your cervimeter you have sievert also, you have Röntgen also. Got it?
Yes.
So Röntgen. So this 1.2 Röntgen is required for D7. That means I will calculate my time such that the radiation passes the object completely and exposes the film. How much exposure is required? 1.2 for D7. Minimum. Then if it is required 1.2 is completed, then only you develop, then you will get an image. If less than 1.2, finish. If more than 1.2, of course dark, overexposure. But minimum 1.2 is required. So your time is calculated for 1.2 Röntgen for D7. Okay. For D4, it is 3 times 3.6. So that is why your time is, if it is 2 minutes, it is 6 minutes. Okay. Why? Because here, see, these are the crystals. Silver bromide crystals in D7 are bigger. In D4 are very small. Something like that. Sorry. Okay? Let us not forget it. It will take waste of time. So small parts are there. Here big are there. So what happens? Once big is heated, so it will take, obviously 1, 2, 3, 4, 5, 6 are there. Here 100 are there. Or 18 are there. So more time for D4. Again, shall we revise what we discussed? What we discussed?
No.
Good, eh? Okay. So now let us go to the topic. Now what happens? So you are having good contrast in slow filling, and your total contrast is radiography contrast, which is subject contrast plus film contrast. Got it? Okay. Let's go to this topic. Now, process of developing. Let us discuss the process of developing. Okay? We will go to the topic, another topic. What is development? Tell me. Did you develop films? Did you do it? What did you do? First stage. First in the developer. Okay. What next? Stop bar. What next? Sure? Sure, eh? I am not good. Tell me, you did not develop? Did you develop or not?
After
Okay, what next? Eh? You don't have wetting agent, something like that? You don't have. I'll tell you about that. But to happen all these things, you need to have one more thing.
What is the writing?
I'll tell you at that point. Exposure of film. Okay. This after the film exposing, developers, you will process the film and you will get and what is the result? You will get permanent image. Okay. You know olden days photography? No flash. Real photography, you know?
Mm.
That is something like this. Same. Okay. First, what happens? Let us understand. When you radiograph an object, you put a film, okay? What happens? You are exposing it, right? So what happens? During exposure, what happens? Your silver bromide is exposed. So what happens? Your silver bromide is like this: AgBr, right? Ag is silver, Br is bromide. When exposed, what happens? Ag, the distance will increase. Ag plus and Br minus. Correct. When radiation passes to the film, it happens. Ag plus and Br minus.
Separate.
Separate. It will separate.
Separate.
Yeah. Correct. Okay. So what happens now? This stage is called latent image. Latent. You know what is latent? Latent. Okay. See what is latent. What is the meaning of latent? In Arabic, I will say. Tell me. Ah. Means what?
Stay.
Huh?
Like stay or
Ah.
not move.
Yes. So what happens here? You took a film. You loaded it.
Take rest.
Okay. You exposed. You bought the film. You find any image. You took a film. You exposed it. Take out the film. Did you see any image?
No.
But the image is there.
Yes. Yeah.
This is called latent image. That means it is hidden. You saw that, no? It is hidden. You cannot see. But there is image.
Yes.
But you cannot see. So this, during exposure, this is called latent image. Okay? Now latent image, you take the film. Now put it in the developer. What happens in the developer? Okay, now I will draw a developer. This is completely developer. Okay? I will put the film here. What happens? You know electron, no? Electron. This developer will give an electron. And electron is negative charge. Right?
All negative.
All negative. Electron is negative. So it will hit an electron. And it will become Ag. Plus and minus cancel. So this becomes Ag. And this developer will take bromine. It will take bromine and it will create Ag. This Ag is black. That is why you have black.
Black, but local black.
Yes.
So we use.
Yes. So you are getting a black image. Okay. Now, after developer, what happens? Can you see the image?
No, we can see, but not clear.
So this is called visible. Now latent image is during exposure. This one, developer stage is visible image. You can see.
You can see. That's a
No problem. Now, stop bar. Why you go for stop bar?
To stop the
Action of developing. Very good. Now, why you go to fixer?
example, like lost one.
Yeah, you're right. But I don't. Technically, what happens in fixer? See, in the film, as I told you, there is the big film. For example, there is a film, and there is silver bromide, right? Your radiation comes, and maybe it will expose this one. It will not this one. It will expose this, but not this. Yes, this, but not this. So this not one developer is not doing anything. So not one is removed in the fixer. In fixer, not exposed silver bromide is taken. All silver bromide. All silver bromide. Yeah.
Not bromide.
Not silver. Not silver bromide. Yeah. Which is not exposed. If exposed silver bromide, talak. Silver bromide. If not exposed, silver bromide are like this. If radiation silver bromide. Like this. Radiation comes, silver is here, bromide. Now,
And develop.
develop
No bromide.
bromine gold, silver is there, black. Okay, not develop, fixer. Got it? Then what happens? Now after fixer you can on the light. Permanent image. Image is permanent. So your third stage is permanent image. Okay?